everyone. Today I'm going to talk to you about two subjects, enzyme and inhibition. And when we talk about inhibition, I'm going to talk to you about competitive inhibition and non-competitive inhibition. So actually the enzymes I'm going to refer today are Michaelis-Menton's enzyme, and those enzymes are regular one. They're the first enzyme that were discovered, and all the equation we're going to use today are according to Michaelis-Menton equation. So this is something I think a very basic one needs for another tutorial. I'm not gonna say I'm going to do a tutorial like that, but if you would like, I'll be happy to try and find the time to do that. So actually, what enzymes do? Enzymes are, if we talk about biochemistry, they are protein molecules. And what they actually do is that they stabilize the transition state. So now I think I talked gibberish, and I'm going to explain to you what I meant. Okay? So each reaction we have, like in here, we have the reactants and we have the products. Okay? In order for the reaction to take place, the energy of the products must be lower than the energy of the reactants. Okay? And this value is called delta G. Okay? And this delta G needs to be smaller than 0. Okay? Negative. In order for a reaction to take place. So if they ask you in an exam if enzyme change the delta G, they never change the delta G. They can only help in cases where delta G is negative. Okay, so this is the first point that I want you to all know. Okay, this is the first point I want you to all understand. Okay, so actually when the delta G is minus, the enzyme lowers the energy of the transition state. So if this is like minus enzyme, this graph here, the graph with the enzyme, okay, I'll do it like plus enzyme. My page is almost over, I'm sorry. The graph plus the enzyme makes the transition state energy lower, okay? It means that more molecules of reactants will have the sufficient energy to become a product, because in this point, in this peak, okay, in this highest point, this is the transition state, and this is an actual state. It's something in the middle. It's not a reactant and it's not a product. Okay, it means that this molecule can become or a reactant to make a reverse turn, or to become a product. Okay, so the enzymes stabilize this state and make the reactants become product in a quicker way. Okay, so this is a very good. Okay, so as we said before, if we look on this diagram, we'll have a lot of diagrams today. We have the concentration of the products, and we here have the time. Okay, the time. So you can see here we have the enzyme. Okay, we have the enzyme, and we can see that we get, if we look without an enzyme or with an enzyme, we get in, like, if we take it like 5 minutes here, we get more yield, more products with the enzyme than without the enzyme. But if we put, like in a bowl or something, or in a flask or something, a very measured amount of substrates, okay, we actually will get the same yield, but we get it faster, and this is what